Okay, this is 6B, measures of variation. In 6A, we talked about how to describe data. We looked at the variation, we looked at the modality, we looked at the skewedness. And sometimes we don't want to look at all the data. We want to look at just some very specific values that tell us a lot of information. So what we're going to talk about today is quartiles and the 5-number summary. And we'll see what these are as we go through. But let's do some definition. The first one is the range. And of course, it is the difference between the highest and the lowest data values. Okay, it is the most basic way to measure variation. Is, well, what's the largest value, what's the smallest value, and let's look at what the difference of those is. So to find the range, we take the highest value minus the lowest value. Now, as we do this, we are going to look at the lowest value and the highest values in what we call a box plot. Everything is going to go in between these two values, and we're going to look at some specific values in there. The median we already know. The median, which will be this value here, is the median of the entire data set. So if I have all these data points, we know how to find the median. We're going to count in, and that's going to be our value in the middle. So those are 3 of our 5 values. Then we're going to look at the lower quartile, which is this value here. It is the median of the lower half of the data. So we're going to look at just this and count in and find the median, the middle value there. Our other value, our 5th value, is the upper quartile, which is this value here. And it is the median of the upper half of the data set. So I would look here and I would count in, and this would be my median. Now notice this space and this space and this space and this space, none of them are the same width. Because remember, the median is the middle value, not the average, so it's not going to be right in the middle. But here's what we do with this now. Now that we have these 5 values, we create what is called a box plot, which is also called a box and whiskers. Okay. And what we will do for that is, once we have these data values, between the lowest and the lower quartile, there is 25% of the data. Between the lower quartile and the median, there is another 25% of the data. Between the median and the upper quartile, we have another 25% of the data points. And finally, between the upper quartile and the highest, there's another 25% of the data values. And that is the number of values, not anything about what their value is. And then, of course, from here to the middle is 50%. And from the median to the upper is another 50%. So this tells us the width of the box, or the width of the whiskers, tells us, well, how much variation is there within that data set. Okay, so this is probably going to be easier if we create our own and we are able to look at where those 25% lie. So the first example here, it represents 11 test grades for a fictitious contemporary math class. Okay, fictitious means I just made it up. So we need to find the lowest value, the highest value, the median, the lower quartile, and the upper quartile. And in order to do all of that, the very first thing I want to do is I want to put them in order. Then all of the values kind of jump out at you. Okay. So if I look here, I see that 35 is my lowest value. Then the next highest value is 70. Then 75. Then 80. Then 82. Then 85. 87, there are two of those, so I have to list it both times. A 90, a 95, and finally a 98. So just to make sure I got them all, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Okay, so what's the easiest? I know that my low value is 35. I know that my high value is 98. And I am now going to find my median next, because I'm going to look at this entire data set and I got to find the middle of it. So if I start counting in, I see that 85 is my median. Okay. All right, so from here, now to find the lower quartile, I am going to start counting in here, and as I do that, I see there are 2 in the middle, so I'm going to have to find the mean of those, which means I take 75 plus 80 and divide it by 2, and my lower quartile is 77.5. To find my upper quartile, I am going to do the same thing. I'm going to start with the median and the high and count in, and I see here that once again I have 2 values. So 87 plus 90 divided by 2 gives me an upper quartile of 88.5. Now, just looking at the data in order, there are a couple of assumptions we can make. 35 is kind of an outlier. Somebody had a really bad day. It was the only failing grade. Everybody else did pretty well on it. But that will become apparent as we go through this. But to find the range, remember it is the high value. It is going to be 98 minus 35, which is going to give me 63. We talked about outliers a little bit last time. 35 is probably an outlier. Okay. All right, so now we're going to create our own box plot. Now, our box plot, it does not have a vertical axis. It only has a horizontal axis. So these are going to be my test grades. Okay. And I need to scale this. This, of course, is 0. But I think if I go up by tens, everything will fit. 10, 20, 30, 40, 50, 60, 70, 80, 90, yeah. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay. So notice here, for each of these values, I'm going to put a vertical line. Doesn't have to be big, I'm just going to put a vertical line. So at 35, I'm going to put a vertical line. Whoops, didn't mean to do that. At 77.5, I'm going to put a vertical line for my lower quartile. At 85, I'm going to put a line for my median. At 88.5, a line for my upper quartile. And then finally, at 98, is going to be my highest value. Okay, so the easiest way to do it to me is to draw this. These in the middle are going to form your box, and then the outside here are going to be your whiskers. So what this tells you is that 25% of the grades were between 0 and 77.5. 25% were between 77.5 and 85. 25% of the grades were between 85 and 88.5. And finally, 25% were between 88.5 and 98. And you can kind of tell because of the length of this whisker that this is going to be an outlier. Okay, let's go ahead and do some more. All right, the 5-number summary describes the variation, but we want to consider how far data is spread from the center. Oops, I think I skipped a page. Uh-oh. Here we go. Okay. Whoops. Okay, I thought something was a little off there, but you know. Okay. The following represents the commute times for 15 workers who live in Austin. So the time it takes them to get to work, school, whatever. It goes from 5 minutes to 60 minutes. I think this was probably done a while ago. To find the range of the values, these are in order. So I take the highest minus the lowest, which gives us a range of 55. So once again, I know my low value and my high value, so I can complete the low and the high in the 5-number summary. So the low is 5, the high is 60. Okay, so let's count in, and next, of course, we want to find the median, which is going to be right in the middle. So if I count in, I see that 20 is my median. So 50% of the commute times are below 20, 50% are above 20. Okay, so let's find our lower quartile now, which is the median. If I start here and start counting in, I'm going to have to take the average of these two. Of course, the average of 10 plus 10 divided by 2 is just 10. I'll do the same thing for the upper quartile. I'll start here and start counting in. And once again, I have 2, so I'm going to have to find the average. So 30 plus 30 divided by 2 gives us 30. Okay. Now, hopefully in class I would have asked you to do this on your own, but let's go ahead and do the same thing for commute times for 20 workers who live in Houston. Okay, so once again, they're given in order for you. So they go from 5 to 85. Oh, wow, that's a huge commute time. All right, the range of the values is going to be 85 minus 5, which is 80. I know my low is 5, my high is 85. And now, since they're, well, let's just count in and see what happens. 7, 8. Okay, so for my median this time, now my median, I'm going to have to find the average of those, which the average of 20 and 20 is just, of course, 20. But now when I count for the others, I'm going to have to start in the middle here. So that means I'm going to go 1, 2, 3, 4. And to find my lower quartile now, again, I'm going to have to find the average of 15 and 15, which of course is just 15. And then here, let's see, 1, 2, 3. Here I'm going to have to find the average of 40 and 45. So 40 plus 45 divided by 2 is going to give us 42.5. All right, so I'm going to create box plots for both of these on the same grid. And since we can see Houston right here, I'm going to go ahead and do Houston. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12. Okay. Let's go up by tens again. So we're going to title this commute times. This will be 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, and I don't think I need to go up any further than that. Okay, so for Houston, the low is 5. The lower quartile is 15. The median is 20. The upper quartile is 42.5. And then the maximum is way over here. It's 85. Okay. So these three in the middle form the box, and then I attach them to the ends with a whisker. All right, now looking back up on the stuff for Austin, the low is 5, the lower quartile is 10, the median is 20, the upper quartile is 30, and finally the high is 60. Okay. So if I draw a box around these ones in the middle, remembering what that means, 50% of the commute times are between 10 and 30. Or here, 50% of the commute times are between 15 and 42.5 minutes. Okay. All right, so write a sentence to describe the shapes. The shapes are similar, but they are similar, but they seem to be skewed right. This spread out here means that the data is going to, if we were to draw a box plot about this, it would look very different. I'm sorry, I mean a histogram. Okay. Now, it is skewed right. Why? If you look at this, remember from here down, this is 75% of the data. 75% of the data. 50% plus 25. It is skewed right. Most commute times are shorter with just a few longer times. Okay. Well, since it is skewed right, write a sentence to describe the centers. The centers are similar. But what does it mean about the typical commute times? Well, since they are skewed right, is skewed right, the median is the center of the data and the typical value. The variation is different. The range in Houston is larger than Austin. So Houston has a greater variation. Okay. Okay, well now we'll go back to the next page that we were supposed to. So in our next page, the 5-number summary describes the variation, but we also want to look at describing variation by considering how far the data is spread from the center. And that is our standard deviation, which is abbreviated with a lowercase or an uppercase s. Okay, now deviation is the difference between a data value and the mean. Notice we're looking at the mean this time, not the median. Standard deviation is the typical distance of the data from the mean, and we abbreviate the mean x bar. So instead of comparing everything to the median, we are going to look at the mean when we're dealing with standard deviation. Okay. Now, calculating the standard deviation is a long, arduous process. It's on page 390 in your textbook, but we're going to give it to you. I can show you if you want how to do it in Desmos or in your if you have a graphing calculator, but there's really no need for that. And I also want to tell you that the standard deviation is used mostly, the standard deviation is the most meaningful with symmetric distributions, which is what we'll talk about in 6C. But we're going to just talk about some generalizations of them here. Okay, so let's talk about what we can do and how we can find relating the range to the standard deviation. And we call that the range rule of thumb. If we know the range, we can estimate the standard deviation by taking the range divided by 4. If we know the standard deviation, we can find the lowest value and the highest value. They are approximations. They don't always work with skewed data. Well, very infrequently do not work with skewed data because we're dealing with the mean instead of the median. And remember, in skewed data, the median is the center of distribution. Okay. All right. So let us look back now on the commute times in Houston. We are going to start out by finding the mean of the data. Okay, and we're going to round that to the nearest. We're just going to find the mean. Okay. What does that mean? That means I'm going to find the total of the values divided by the number of values. So if I add all of these up, let's see if I've already done that. I don't think I have. Okay, so let me get my calculator out and add all those up. Okay, so if I do that, and I'll allow you to do the calculations, but we get that this is 30.25. All right, now we're going to, if we have the mean, we can use the range rule of thumb to estimate the standard deviation. Well, in order to do that, I have to find the range. Well, the range is the highest value minus the lowest value, which is 80. So to find this, I take 80 divided by 4, which gives me a standard deviation of 20. Okay. All right. Now, if you were to find the actual standard deviation, and again, I'm not ever going to ask you to do that, the actual standard deviation is 21.91. Did this work well? Yes. It was close, but a bit lower. So it's not too far off. All right, well, now we're going to use the range rule of thumb to estimate the lowest and the highest values. We know that the actual low is 5, and the actual high, whoops, I'm sorry, you can't see that. High is 85. Okay. All right, so to find the lowest value, it is going to be the mean minus 2 times the standard deviation, which is going to give us 30.25 minus 2 times 20, which actually gives us negative 9.75. To find the highest value, it is the mean plus 2 times the standard deviation, which is 30.25 plus 2 times 20, which gives us 70.25. Okay, now, this was not too bad. This was not too far off. But notice these are way off. So compare the actual lowest and highest to, did the rule work well? No. And here is why. The median, if we go back in and look at our data, the median is 20 and the mean is 30.25. They are different because the data is skewed right. And the range rule of thumb works best for symmetric data. Okay, on that note, I'm going to switch videos.